Hi, I got a diesel pump electronics control unit, and let's see if we can fix it. The first impression I got is that this unit has been fixed before. The second was a surprise. Just listen to it. It looks like it has something loose inside. The bottom piece is just a flat, thin aluminum. The rest of the box is heat absorbent. So before it takes all our heat and bring it to the surface of the radiator, we have to ensure we have to heat the bottom first, where our silicone glue is sticked. Let's go now for the opening. If it is ready. If not, we have to continue heating the box. It's not ready yet, but we can hear some at this. You can hear a little bit of deflection. I will trap it inside. Okay. Done. From the movie How to Fix from YouTube, we got this situation. Some people, they watch on YouTube and they say, okay, there is a problem here and try to make a bridge here. Okay, they did it. But we can see here, there are some heating problems. And the soldering is damaged, and we can see some material could be from the flux, could be from the melting of the painting in the printed circuit board. When I said I'm sure it's soldering problems, look that. What do you think about? Let me take a picture so it will be a closer view. The really hard part is this capacitor. And that's the reason why our super last technician couldn't do the job right, because we need a very high watts or high power soldering iron to solder that and to take it off too. Okay, I remove everything. In the good theory, here I have a small transformer. I should not remove the soldering, but my experience from another cases, sometimes it is sticked with the silicone glue under it. So my best recommendation before I start fighting with it and forcing it, release those 4 points too. Now let's see what can we do. Okay, here is coming out, here too, and the whole thing is out very easy. After, let me tell you the truth, hours fighting. And this is not silicone. Pay attention to it. Sometimes we don't need special equipment to find mine problems. This is not silicone glue. Here we have a spot, but the silicone still flat. What we have here is what was inside of this resistor. It's a 0.02 ohms in plus minus 1%. It's a very important device, and when we use in electronics very low resistors, most of the time they are not only for to limit the current, they are to make a voltage drop across it, so we can take measurements of the power we're applying to somewhere. One of the most punished devices in the whole process is the capacitor, because we have to use a 60-80 watts soldering iron to release the solder, and also because it's own job. So don't ever forget to test it. This is the positive, there the negative. We are expecting to find 1500 microfarads. So far so good. Against the other lead. Okay, it passed. Our next capacitor is 10 microfarads. The first one, we don't know what is it. It could be a voltage regulator or something like that. It's a chip. By the way, it's the only one that has white writings. I will not check for the code because I know this kind of thing has their own codes, so will not be there so available on internet. Pay attention to it. This one is a MOSFET. If I put the red lead here and the black here, it shows 0. If I trigger off, now it's an open circuit. If I trigger it on, it's conduction again. Can you follow the game? Okay, this one is good. The third one is a double diode. If you put the red lead in the center, you will see two identical diodes on each side. There is no conduction on the other way. Fourth one. Once again, we got a MOSFET. Triggered on is conducting, off is open. On is conducting, off is open. I will do it with the second because it's easier to see. But let me catch the tester for you. Okay. Maybe this is a closer view. Trigger on conductive, off open. Pay attention to the tester. First lead, out. Okay. So we know the first one we don't know, could be a voltage regulator. Second one is a MOSFET. Third one diodes. Fourth one MOSFETs. Here same than the third. They are diodes. Pay attention. From the center to one side, one diode. To the other side, identical diode. They're identical because they are twins. Same process. Okay. 1, 2, 3, 4, 5, 6. MOSFET. Pay attention to it. It's an open circuit. Trigger the gate. It's a closed circuit. Turn it off. There is no conduction. Trigger it on. There is conduction. Turn it off. There is no conduction. Okay. This guy is a MOSFET. Surprise. Look this other guy. 0. Almost 0. Everywhere. Doesn't matter where do you want to try it. Everything is 0. I will move the tester for you to have a closer view. If we pay attention to it, see it again, all the leads, from here to here, from here to here, any direction. Okay, whatever it is in short circuit, all the leads. So next step is to remove it. But we have some stuffy, very well compact glued silicone. Before to start operation and to remove the silicone, the first thing I'm going to do is to take this transformer and put it back in the printed circuit board because I don't want to miss its position. Okay? I'm not sure if it is no, I'm totally sure now. Could be one-to-one transfer, but now I can see that the wires, they have different size. So I will take it out, put it in the circuit board, and later come back to work here. There are different ways to get this radiator out. One is to shovel on the silicone and take it off, piece by piece. Two, I do not recommend it to use a hot plate to heat the silicone. I do not recommend it because capacitors like this could be sensitive on 85 degrees Celsius, 105 or 125 like this one. Probably we have to go about 120 and expose some time, a longer time to melt the silicone. Let's see if we can find another way. One trick to apply is first try to cut the silicone until deep inside. I already did it, that's the reason why it enters so easy. Until deep inside to help to release the radiator. Once that you use a tool like this, later you can use a saw knife like that. Pay attention. We don't want to touch this transformer. Okay? So be very careful about it. When you're here, be very careful. Also, sometimes the screws, they are very long and they will be on your way. Don't get surprised about it. And later, we're going to apply another trick. Okay guys, first time you watch it in YouTube, we're here. Here you go. Easy. Let it cool down. Let's go for dinner. And I will tell you why I don't want to kill all this silicone, because we need it. This is a diesel car with a lot of vibration, and in a country with a lot of bad roads, and probably all the soldering will break down if there is not good stuffy silicone like this one. So it has a reason to be there. We will keep it. If we pay attention to it, do you remember this point where the source should come from the two transistors and the short circuit one? Okay, it comes to this point on the diodes. Everybody, I don't know why in YouTube, maybe because somebody got a burned printed circuit board and this it opens, they have to make a jump. Not for us in this case. We don't need it, and pay attention to it. If I make a strong jumper here, next time that something burns, this printed circuit board will not work as a fuse. So some way, somehow, it is like a fuse. It's okay. I want this thing to burn and not this other one to resist, because if the printed circuit board burns and becomes in a piece of carbon, will be conductive and I have to trash the whole thing. So do it right. No, don't follow them as they say because they don't understand and somebody did it. Oh, by the way, do you remember the wire? It was not a wire, it was a solder line. Very funny thing. Genius. Okay, we said from this point we come to this other in the diode. Here we have a transformer. Now from this point, if we check, we have the capacitor, the positive of the capacitor. The capacitor is 35 volts. They are in parallel because they need a lot of current, but the capacitor, remember, is placed for 3 times or twice of the voltage we need. So if you don't know with what to substitute this guy, let me tell you, in diesel pumps, sometimes I make a measurements of peaks of 16 amperes. So from 16 amperes in pulsing, pay attention because when you get the data sheet, you will get the constant current and the pulsing current. I will look for a guy with a very high current for it. The fabricant used the same one for all of them because their product can supply the high voltage that we will get somewhere around, and that high voltage could be like 160 to almost 200 volts, sometimes in peaks that we can get on the tester. And probably they are working with 400, 500 volts MOSFETs, and probably they are working with MOSFETs that will give us very high peaks of currents like 30 amperes or something alike. In my case, I don't have the right supply, piece to replace it. So what I'm going to do, I will leave the ones with the high voltage as they are because we need it there, but I will look for a one with high current, and I will put 2 of them because those guys, they are in parallel and I need them to be twins from the same specifications, and I hope the same brand and from the same productive line. So remember, this this and this guy, they are transistors, MOSFET. They should be high voltage, about 400, 500 volts peak. All of them, they must have a very, very low resistance in the gate. Those ones, they must be very high current. So think about it when you're going to look for a replacement. I will not give you one specific number because it will be more depending of what you can find in your market or what you have in your stock.
Electronics fixing is not just to watch what somebody else did to do the same. It involves knowledge, equipment, and a lot of common sense to try to fix something. We saw here when somebody just watched a video and did things with no sense. I hope you enjoyed. Thanks by watching it.